everybody, and welcome to our discussion about, when logic starts to get hard. Now, sometimes when we are talking about arguments, we are talking about arguments that are relatively easy to understand. We're talking about arguments like, if you want to make an omelet, then you're going to have to break some eggs. In other words, very simple statements that end up being transformed into something that's relatively easy for us to parse when it comes to validity and soundness. But what happens when these arguments become more complex? What happens when we introduce more than just one or two variables into something? Well, that's what we're going to talk about today. Today we are talking about symbolic logic, and in particular we're talking about two methods that are going to help us understand how to parse these different complex statements and complex arguments that we're facing. We're going to talk about truth tables, and we're going to talk about what I call the shortcut, or what the book would call the streamlined method. So before we get into that, let's go through some basic terms that will be helpful for understanding what exactly we're talking about. Now, the kind of logic that we're talking about is called symbolic logic, precisely because it uses different symbols to represent or demonstrate certain classes of things and relations between things. So, for example, you might already be familiar with some of these. You might be familiar with this symbol right here, which is the symbol for a disjunction or a disjunctive statement, either P or Q. In like manner, you might be familiar with this symbol right here. If P, then Q. Right? What we have here is an antecedent and a consequent. What we have here are two options, two variables that we can play around with. And what we have here is a term that joins, or a symbol that joins or describes the relationship between these terms. But to this we can add a couple of other different symbols that will be very helpful for us. For example, when we add a tilde to something, it becomes not P. Right? We are saying that something is not present. So rather than saying that P is there or eggs are present, we are saying it is not the case that eggs are present. One additional relationship that we need to talk about is that of and. Right? I might demonstrate this with a plus sign or with an and. You might use an ampersand. I'm not going to try and draw an ampersand here, but it is a relationship P and Q, right? It's talking about both of these have to be present. Now, each one of these types of statements has to be it has to meet certain conditions in order for it to be a true statement. And if those conditions aren't met, then it isn't a true statement. Now, when I'm talking about truth here, you might be going, hey, wait a second, didn't you talk about arguments really being about whether or not they work, not whether or not they're true? And you would be correct. Early on, we talked about focusing on validity or an argument working as opposed to talking about the truth or non-truth of something. Well, we're not talking about arguments yet. We are talking about statements. And when we're talking about statements, we're talking about premises. Premises can be true or false. The information that you present in an argument can be true or false. The argument is about the relation between the terms, but the terms themselves, the statements themselves, the premises themselves, these are all elements that have a truth value. And a truth value is represented very simply. It's either true or it's false. So let's look at these different kinds of statements and try and assess their truth value. The first kind of statement we're going to look at is a conjunctive statement or an and statement. So I have P and Q here, right? For this type of statement, for a P and Q, for a conjunctive statement, the condition for this to be true is that both of these terms have to be present. Right? Both of these terms have to be present, because if I'm saying something like it is cold, the weather today is cold and rainy. If it's only cold, I haven't told you the truth. Or if it's only rainy, but it's like a very hot summer day, and so it's like sweaty and kind of like humid and gross, and it's raining, but it's not cooling you off, well, I would definitely not be making a true statement. A true statement of a conjunction happens only when both of the terms have a truth value of true, when they're both the case. When we get to a conjunctive statement, if P, then Q, we have a couple of scenarios where this can be true. So for example, the first one is if you want to break an omelet, or if you want to make an omelet, then you need to break some eggs, right? Well, this is a true statement because both of these are true. Another case where it would be true would be if neither of these conditions has been met. And you might wonder, well, why is that the case? It's a true representation of what's going on here, because the relationship, right? The relationship between these terms is not undermined by the condition, the truth value of the individual components. It is still maintained that the relation is there, right? There is one other situation in which a conditional statement would be true, and that is if this is not met, but this is met. Now, why is that? Because this term, if this term is present, then this term will be present as well. So it's about the relation between the two of them. If you are making an omelet, then you have broken eggs. You could break eggs and be making a souffle. You could be making, I don't know, some other recipe that calls for eggs. There turns out to be a lot of recipes that call for eggs. A lot more than just making omelets. Again, the key here is that we are talking about the relation between the terms. We're talking about the relation between the consequent and the antecedent. And only when we have statements that have truth values that affirm that relationship are we able to actually say, oh, this statement is true. So when we get to other kinds of statements, in particular when we get to an either or statement, we might have a different set of affairs, right? Either P or Q, right? Well, it has to be the case that one of these is met and one of these is not. I'll put it this way for you. There we go. Right? So either it is the case that P is present or Q is present. Either it is the case that P is present or Q is present, and that makes it true. But there's one other instance when it would be true, and that is if both of them are present, then it is true. And you might be wondering, well, why is that the case? Well, in standard practice within symbolic logic, one of the things that we try to do is have an inclusive disjunction. It sounds counterintuitive, but the idea being that let's say that you are going shopping for presents for Christmas or some other holiday, and you say, either I'm going to get a game for my beloved family member, or I'm going to get mittens. And you go to the store and they have both games and mittens, and so you buy games and mittens. You have not disaffirmed the intent of the statement, right? I'm going to get a gift, so I need to get either this or that. Well, you could get both. It would be false if you got neither, right? It would be false if you got neither. It seems counterintuitive, but for our purposes, let's just go with this inclusive disjunction. So one more thing I want to say, and that is about negations. So if I add a tilde to a particular term, right, what I am doing is I am saying it is not the case that whatever that term or that statement is, right? I'm saying something like, it is not the case that you need an umbrella today. And so somebody comes in from outside and they're drenched and they say, well, it is not the case that you need an umbrella outside. In other words, they're saying you need an umbrella outside. Basically, when it comes to a negation is saying something is not the case. If you negate the negation, it is essentially the same as just saying something affirmatively. So when it comes to talking about these different statements and putting them together into arguments and then trying to test for the validity of these arguments, we have a couple of tools that are at our disposal. One, the truth table, is far more involved, but the other, the shortcut or the streamlined method, also can give us some insight into whether or not we're dealing with something that is valid or invalid. So when we are looking for validity, we are looking to find a situation where we have all true premises and a conclusion that is true. In order to determine whether a particular argument form is invalid, valid or invalid, we have to find a situation where the conclusion is false but the premises are true. Right? Because validity means that it is impossible for the conclusion, the premises to be true and the conclusion to be false. Right? It all flows together. So when we are dealing with our arguments and using a truth table, the first thing we want to do is we want to make sure that we have our guiding columns here. And I've set them up just for where there's two variables. We'll get into it a bit more thoroughly and have to add columns as we add more variables. So let me just pull up an argument real quick. So let's say that we are working with the argument, if P then Q. P is not met, therefore Q is also not met. So what I'm going to do is I'm going to draw some columns, and I'm just drawing two because that's the conclusion. And we'll draw our line across like that. And I will just check on something real quick. Okay. Hopefully you'll be able to see it. I'll try and move out of the way. But if you can't see it, you have my utmost apologies. So we know that once we have our guiding columns here, we need to address this particular statement here and the relation between these terms. Now, these terms are in a conditional statement. And so we can think back to which conditions need to be met in order for a conditional statement to be regarded as a true statement? Well, if P and Q are met, then it is regarded as true. If P is met, but Q is not met, is it regarded as true? If both of them are not met, is it regarded as true? So we know that if the antecedent and the consequent are both true, then the conditional statement is true. We also know that if the antecedent is false, but the consequent is true, it's also a true statement, because whatever the consequent may be could also occur without the antecedent occurring. But it is not the case that the antecedent would occur without the consequent. Okay? You could get Q, but you don't get P without Q. All right? And we also know that down here, this relationship remains intact even if both of the terms, both the antecedent and the consequent, are false. So that is also true. But it is not the case that when the antecedent is true and the consequent is false, that the statement is true. So we know that at least in this instance right here, that statement is false. Now here we have not P. So what we would do is we'd put in, it is not the case that P. So we'd put the opposite in, right? So we'd put false there, we'd put false there, we'd put true here, we'd put true here. Okay. And then we would also put those same values in over here. So if it's true here, that means it's going to be false here. That means it's going to be true here. That means it is going to be false here, and it is going to be true here. So what are we looking for? We are looking for a situation of invalidity, a situation where you have all true premises and a false conclusion. This argument is invalid. And we can sort of, in a very common sense way, think about this. We can say, it seems like it's the case that if I don't have this, it doesn't mean that I don't have this. Why? Well, because we talked about it here, right? It's not the case that if I don't have the antecedent, I also don't get the consequent. I could still get the consequent, but it could be a totally different reason for why, right? So we might think about it. If you want Christmas presents, then you need to send a letter to Santa. You don't want Christmas presents, so you don't send a letter to Santa. Well, just because you don't want Christmas presents doesn't mean that you don't send a letter to Santa. You and Santa could be best pals. You could, write each other letters or send each other funny vines, or vines aren't a thing. Vines haven't been a thing since like 2016. What am I talking about? I'm old. Send each other TikToks that have Santa's vibes or something like that, right? This is an invalid argument because it has a situation where there are all true premises and the conclusion is false. So now that we've already talked about a relatively simple version of an argument and tried to find validity or invalidity using a truth table, we're going to try this with a little bit more complicated argument. And in order to do that, we're going to introduce two new elements. The first element we're going to introduce is another variable. And the second element we're going to introduce are parentheses. And you might be wondering, well, why would we introduce these types of elements into these arguments? Shouldn't we be able to do it with relative ease? And the answer is, well, some relationships are more important than others, and that's what parentheses allow us to say. For example, I might be making the argument, if it snows tomorrow, then Timothy and Bulbasaur will go outside. I can represent that argument in the following way. I could say, if it snows tomorrow, then Timothy and Bulbasaur will not go outside. That's the argument I'm trying to make. If it snows tomorrow, Timothy and Bulbasaur will not go outside. So I would say, Timothy and Bulbasaur will not go outside. Now, I can symbolize it in such a way that I put these parentheses around here. And if it snows tomorrow, then it is not the case that Timothy and Bulbasaur will go outside, right? Because here what I have is Timothy will go outside and Bulbasaur will go outside. But if I shift where those parentheses are, I shift the statement entirely. I could put them here. And I would have a very different statement. I would be saying, if it snows tomorrow, then it is not the case that Timothy will go outside and Bulbasaur will go outside. Simply by shifting where these parentheses are. But if you'll notice, these parentheses and adding additional variables allow us to make more complicated statements than a simple, if you want Christmas presents, then you send a letter to Santa, right? That is a very simple statement, but this is a whole new set of conditions that we're attempting to deal with. And when we are making arguments about what happens in the world in which we live, we need more sophisticated tools. We need more sophisticated forms of argumentation because the world we live in is complex. We might say, oh yeah, this policy is great, except in cases where these conditions exist. Then this policy needs to be amended in order to account for this condition in the following way, this other condition in the following way. And all of a sudden now we have tons of variables and there are parentheses all over the place. And it's necessary because if we are trying to get to more complex and truer arguments and a truer understanding of the world, we need tools that can account for the complexity we find in the world. So let's look at a trickier argument, right? And this argument is going to be both dumber and trickier. It's dumber for your entertainment purposes, but it's trickier in terms of the formal constructions and logical syntax that we use. So let's use this silly example. If you added peas to your spaghetti, but you did not add marinara sauce to it, then you were only guilty of one food crime. Unfortunately, it is not the case that you only added peas to your spaghetti but not marinara sauce. And therefore, it is also not the case that you were guilty of only one food crime. Now, how are we going to represent this argument? This is a complicated thing. Well, the first thing we're going to do is we're going to kind of define our terms. So we'll say P is peas in spaghetti. I'm spelling it entirely incorrectly, but it's always funnier to say spaghetti instead of spaghetti. We will use Q to represent marinara in spaghetti. And then we will use, let me just pull that up, F to equal only one food crime. Okay, so now we have our terms. How do we represent this argument? Well, the first thing that I would do is I would write it out as a logical syllogism. So if you added peas to your spaghetti, but it is not the case that you added marinara to your spaghetti, then you are guilty of only one food crime. Unfortunately, it is not the case that you only added peas to your spaghetti and not marinara. Therefore, it is not the case that you are guilty of only one food crime. All right. So now I have this strange argument here. Let's put it into a truth table, and this is just going to appear for you magically. So the very first thing that I'm going to do is I'm going to set up my guidance columns. So we've got P, we've got Q, we've got F. And so what we need to do is we need to come up with all of the combinations, all of the possible combinations in which these terms are true. So we could start out with true, 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 false, true, false, true, true, false, false. This is just with P being true. So now let's make P false. So P is false, true, true, false, true, false, 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 true. And then finally, down here at the bottom, false, false, false. Okay. So now we have all the way down at the bottom right here, right at the edge of your screen, you can see false, false, false. All right, so what do we do next? Well, we add in our argument. All right, so I have filled out this whole chart here, and hopefully you can see most of it. The most relevant part is really that we are looking for situations where the premises are true, and the premises of the argument are true, and the conclusion is false. So we can see in... and again, bear in mind that this is just what the contents of this particular statement are, right? So if we're going through, it's got to be P and it is not the case that Q, right? So going through P and not Q, if both P and Q are true, this would be false. If both of them are true, it's false. If one is true and the other is false, then it is true, right? And so we get that here as well. But these three columns here, these are the ones that really matter. These in particular are the premises, this one and this one. So we can look and we can see, okay, we have true premises and a false conclusion. We have, let's see, here we go. True premises and a false conclusion. We have true premises and a false conclusion. I have a hunch that this argument is invalid. All right, for the final technique that we are going to be talking about, we are going to be talking about the shortcut. Basically, Here, we're not trying to calculate for every single iteration of the argument in order to determine when it is true and when it is false, so that we can really know if it's valid or invalid. With the shortcut, essentially we're trying to break the argument. We are introducing a fail state to see if the argument fails. And if the argument doesn't fail, then, well, we know that it doesn't fail. But we don't necessarily know that that means that it's really valid. It just means it's less invalid, maybe. This method is good for moving quickly through arguments that might be complex, but we have a hunch actually have something to say to us. So, I've already written up here an argument that we're going to be going through, and hopefully that will help you see what we're going to do. So in each of these statements that I have here, this is a full argument, we are going to assign truth values. So the very first thing that we're going to do is, if we are inducing a fail state into the argument, if we are introducing that, then what we're going to do is we're going to try and create the conditions of invalidity. So if we're trying to create the conditions of invalidity, what makes an argument invalid? Well, when it has premises that are true and a conclusion that is false. For our purposes, that's what we mean by invalidity. So, what do? Well, the first thing we do is we're going to say that the conclusion right here is false. Make a nice big F. Big F. It's false. So we are essentially trying to create the conditions that make this false and the rest of this argument true. Okay? So, what do we do next? What we do next is we add in truth values that are locked in. So if P over here is false, then we know that over here is also false. Okay, so this value is going to be false. And we know that, well, if this is present, then it's true, which makes this part true, which means that this is false, which means that this one is true. Now you might be wondering, why is R true? Well, R is a premise, so we want it to be true. So the very first thing I'm going to do is say, okay, I want the premises to be true and the conclusion false in order to prove invalidity. So I'm going to say that R is true, which means that inside of the parentheses here in this disjunctive statement, R has to be true, which means that it is the case that either Q is false or it could also be true. But in any case, the individual values in here don't matter because the thing itself is true. In any case where R is true, this is true. It has a truth value of true. Now, R is true because we want our premises to be true. And so we add that value in over here, which means that Q is false. Q could also be true, but for our purposes, we want it to be false because all we need is one of these two terms to be true in order for what's inside of this bracket to be true. And we also know that with a conditional statement, right, if we have the antecedent false, but we have the consequent true, it is still true. And going back to the Q, because we said that Q was false, it is not the case that Q means that this is true, which is what we want. So what we have are true, 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 false. We have introduced invalidity. we've introduced invalidity, and we've used the shortcut method. So you can use this for all different kinds of arguments, and what it's going to do is it's going to allow you to run through quickly and see whether or not you need to construct a truth table, because if you can easily prove invalidity, why would you go through all that effort to fill your paper with all kinds of text? So why use either of these methods? What value do they add to our understanding of the world? Well, on the base level, what we have here are two tools for our cognitive toolbox. What we have is a set of tools that allow us to dig deeper into more complicated arguments in order to understand how they function and how we might figure out whether or not they're worth anything at all, if they're valid or invalid. What a truth table allows us to do is understand the nuance and complexity and all of the intricate relations between all of the terms in an argument when it is true and when it is false in terms of these little parts. And what the shortcut does is it basically gives us a kind of counter-example attempt. It gives us a failure approach to try and break an argument to see whether or not it can break. It's a great tool to allow us to test whether or not an argument that maybe we're making is worth anything at all. Adios.